Oh, okay. Um, Good morning, ladies and gentlemen, and thank you for those who are attending virtually. Let me just start by saying that I've been working in the blockchain space for about 3 years, and this is the first year where I'm attending ETHDenver. And all I can say is, wow, I know we're just starting, but I can already feel the energy building up. So let's just start with the basics. My name is Iris, and I'm a product owner for Consensus, more specifically for the Decentralized Infrastructure Network project, also known as DIN. Uh, I have with me EG, who is the co-founder of Infura. And in November last year, we promised at the Decentralized RPC Summit in Istanbul that the next big update on DIN is going to be at ETHDenver. So, nonetheless, here we are. Uh, Today, me and EG are going to give you an update on the progress that we have made on DIN in the past few months. And oh, believe me, this is going to be exciting. But before we begin, I do like to start all my meetings with a dad joke. So unfortunately for all of you here today, this is no exception. So if Eve was a bodybuilder, what would they drink? Whey protein. All right, so now that I've managed to make a fool out of myself, we can actually get started on the proper stuff. So for the next 20 minutes, our presentation will be structured as follows. So first, I'm just going to provide a quick brief of DIN. I'm going to cover the what, why, and how of the project. And this is going to be more tailored for newcomers, as well as those of you who need a refresher on what DIN is. And following this, I'm going to highlight some of our most significant milestones that we have achieved so far. And then I'm just going to hand over to EG, who is going to delve into the current state of DIN. And finally, both of us are going to address the challenges ahead, as well as the next steps that DIN is going to undergo. All right, so what is DIN? I would say think of it as decentralized RPC as a service. In essence, we've designed a network where providers can earn revenue and customers can enjoy endpoints that mimic their current experience. So for example, imagine having one always-on endpoint that connects you to different blockchains. Behind the scenes, though, the traffic is served through a network of providers instead of a single source. And you might be asking yourself, why do this? Well, looking at the provider space through the lens of the Web3 ethos, we have noticed that it suffers from a lot of the common centralization issues. So a lot of the providers tend to be single points of failure, and a lot of them are susceptible to availability issues, whether that's due to technical issues or regulations issues or provider limitations as a whole. So, and also there is an adversarial relationship between all providers, and essentially we're all doing similar things to provide the service, but there is wasted effort recreating our respective stacks. And now that I've addressed the problem statement, let's envision the future of DIN's state of RPC as a service and why it's exciting. As DIN realizes its full potential, users can anticipate an elevated quality of service and an enhanced availability. So this is made possible through the network's provision of geolocation and infrastructure diversity. And essentially what we're saying is that we will be able to find the best way to route requests to you with minimal latency and with costs that fit your needs. Do you want something more specialized, like a specific virtualized method? We got it. Do you seek cost optimization over latency? We can do that for you. And the beauty of all of this is that this will be packaged in a seamless UX experience. So as a user, you shouldn't really feel much difference from just using like a regular RPC provider. All right, so I know a lot of us are engineers here. The next logical question is, how are we actually going to build this? So we are working towards a decentralized model, but the first step we're taking is for building a federation. And the reason for doing this is because it's very hard to start an initiative like this on the right side of the spectrum, and we're trying to build this in a way that it is sustainable and it's scalable long term. And whilst I'm not going to dive too deeply into the diagram that we're looking at here, EG is going to provide a more in-depth exploration in just a few minutes. But what I do want to stress about this information is that there are a few critical roles played by various actors that are going to contribute to basically realizing Dean's vision. So First, we've got the node operators. So these are reliable and robust service providers who are capable of handling high throughput requests at an agreed upon quality of service. And we currently already have a handful of node providers onboarded onto DIN as we are preparing to launch failover for Arbitrum, Optimism, and Avalanche for Infura through DIN. Next, we've got the network watchers, and these are actors who will report degraded quality of service with evidence and periodically test the node providers that I was just talking about earlier in order to make sure that we maintain the quality of service of the network. And currently, the network watchers are in a POC state, so we're going to have more updates for them in the coming quarter. Next on the list, we've got the on-chain registry. So this is also in a POC state right now. We're working very hard to get this up and running. And this is also going to help towards building more of DIN's vision of reaching a decentralized state, where providers should be able to declare their capabilities on-chain. And last but not least, we've got the ingress operators. And one of those, which is the DIN router, which again, EG is going to talk about more in a second. But in a nutshell, these are the behind-the-scenes magic makers that I was talking about earlier. So in terms of our journey so far, in case you're not really familiar with what we've been doing, we started off with an announcement in September 2022 at ETH Berlin, where the idea kind of came to life. And then we've had one hell of a year and a half since then. And we've started, obviously, from the logical things of drafting the white paper to putting up together the acceptance criteria for who we want to onboard on the network, all the way down to September 2023, when we've managed to onboard a first batch of partners, and we managed to meet up in person in New York, where we together tackled a few of the challenges that you face when you're trying to build a decentralized network. And we kept onboarding more and more partners, iterating on the acceptance criteria, working out the economics side of things. And towards the end of the year, we ended strong with a DIN partner announcement at the Decentralized RPC Summit that I mentioned earlier, as well as enabling the first live offering of DIN, which was Polygon failover for Infura. And in the new year, we had further iterations on the router, further iterations on the acceptance criteria, which brings us to February. Last week, we had the second in-person meetup with our partners in Denver, where we made tremendous progress again on all the different working group topics that we're trying to cover to make this a reality as soon as possible and to offer it to you. And we're here today, and on to bigger and better. So I'm going to hand it over to EG.
Cool, thanks, Iris. All right, so what have we been doing for the last 4 months or so since that last workshop? We did this workshop where we were onboarding new participants, getting them involved in participating in the network in various ways. There were some people that wanted to contribute code, some people that wanted to contribute infrastructure, some people that wanted to actually help with the core development of what will eventually be a DIN protocol. And our first focus is building the DIN gateway. In the previous diagram that you had seen showing the different actors on the network, the DIN gateway is one of those ingress operators where traffic enters the network. And the first thing that we have to build is essentially a reverse proxy or a DIN router that accepts that traffic, authenticates that traffic, and decides how that traffic gets routed out to the network. So that's been the focus of our development the last 3 to 4 months. In parallel to that, we've been onboarding providers. We went from initially having a handful of providers in the spring of last year. Now we have, I believe it's over 40 registered RPC and infrastructure providers that are willing to participate or are already working with us on the network. We've been working on expanding the network capabilities. So the initial design of DIN was focused on Ethereum or EVM RPC. And we quickly saw or found that people were interested in having DIN serve capabilities beyond just EVM-compatible networks. So we've been talking to people, figuring out what the use cases are for, or what the requirements are, and making sure that we're adapting our current design in all of the different components, whether it's the router itself, the node kit that I'll get into in a little bit, or some of the other like payment mechanisms that we're designing. Lastly, we started this bounty program, which is intended to help bootstrap demand on the decentralized infrastructure network. There are many talented providers out there that are capable of serving RPC traffic, API traffic, other types of Web3 services, but they are maybe too small to actually go out there and create these partnerships that get them the deal flow that allows them to be profitable. So we as Infura Consensus DIN are trying to do that legwork for people that are participating in the network so that they can focus on running the infrastructure and immediately get access to the demand side that we're helping build. This is a little zoomed in version of the DIN gateway. So this is the federated phase of the network, which means it's not permissionless. It's not like anybody can join it. Infura currently has a business that we're running that's a traditional SaaS, and DIN's journey is transitioning Infura from a traditional SaaS business to a more crypto-native Web3 business model. And the first step in that for us is going through this federated phase. So in this federated phase, there's this DIN router that you see in this like purple color. This is the proxy that we've been building. And because we're building it into the existing Infura service for now, it solves some things for us. Things like how we're going to do user authentication and authorization for the network. We're using the traditional like API keys and typical Web 2 permissions to start, while we decide what we're going to do to actually implement this in an on-chain verifiable way. That work is happening in parallel, but this router is now live because we're able to start routing traffic to some of these providers that we've already connected. Iris was mentioning that our first thing that we did was serve the Polygon network late last year. We're adding Avalanche, Arbitrum. There's a few other announcements coming very soon of the networks that are going live on DIN. The way that they're getting access to those networks is through this DIN router that Infura is kind of in front of right now. So if you're already using Infura, you already have access to, or you will have access to these networks as they go live. The intent is that over time, this gateway is not something that only Infura runs. It's a permissionless thing where maybe an infrastructure provider decides they want to run a gateway in addition to their node infrastructure, or maybe they only want to run a gateway and they don't want to run the node infrastructure. Some of the challenges that we're trying to solve at that proxy level is network capacity, that when you have a single point of entry into this network, yes, the node capabilities behind that are horizontally scalable. We can keep adding providers, adding node operators, but you have this single point that will be that point of failure until we actually start to have horizontal scaling across the gateways. Because of that, in the design, we have to factor in how we're going to provide cross-provider consistency, which means if you're going to the Infura gateway or some other gateway, say there's 5 gateways in the future, you're not going to get consistency across them unless you design it into the protocol right now. And we were exploring some things with how we could potentially do that, use maybe on-chain signals to sync session management across gateways. Our current thinking on that is that gateway consistency is specific to gateways. So when you're interacting with a gateway directly, you have a consistent experience when it comes to the data that you're getting through those API queries. But if you're starting to interact across gateways, that's outside of the scope of the network consistency implementation. Service compatibility is another one where different node operators and infrastructure providers might say, I provide this service or that service, but it's a slightly different flavor. And a user doesn't really encounter that until they run into a bug that actually like breaks their application. So that's one of the things that we're building into the design of the watcher system, which is how it checks and verifies that a service is what it says it is. It's as performant as it should be, and it's meeting the expectations of the user when it comes to the types of responses that it's getting back. And then lastly, extensibility, making sure that in all of the things that we're building, it's extensible not just by the DIN team. We want it to be a community-led initiative to keep adding new functionality to this network. And these are the steps to add a new network or capability to DIN. DIN, while we're initially talking about as decentralized RPC, we really see it more as a decentralized marketplace of APIs and Web3 services. We're starting with EVM-based RPC, but anything that kind of fits this mold right here could potentially be solved on DIN. You need to be able to create a service definition which defines like what does your service look like. For something like the RPC, that means what network is it that it supports, maybe what chain ID it's expecting, what RPC methods are specific to this network. So if you use MetaMask in traditional like EVM applications, there's a very standard set of Ethereum methods, but maybe somebody creates a new EVM fork and it has 12 new methods, or it only has a subset of those. Somebody here can create a service definition specific to that network, then do the work to create a router plugin so that that router or gateway is aware of what these changes are. And then lastly, somebody needs to create a watcher test suite or validation suite, which is those checks that I was referring to. How somebody knows that the service that's running actually is adhering to the specification. We have our first version of the on-chain node registry in development right now. This is a very simple like YAML representation of what that work is. So you can consider the on-chain registry as a list of providers that are available, a list of services, and a mapping of which services are hosted by various providers. So it's not uniform across this. If you're running DIN infrastructure, if there's like, there's going to be this DIN node kit that I'll talk about in a second. If you're running this DIN node kit, it's configurable because of that extensibility and plugin model that I was talking about, where you can pick what you're going to run and support. So that's that extensibility and plugins. Here's an example of a user interacting with the DIN router, and that interacting or sending traffic to this node kit. So the node kit is run by an RPC provider or infrastructure operator. They would be picking and either developing new network plugins and storage plugins to meet the needs of the services that they are planning to offer. Or if you're a ingress operator or gateway, you're maybe adding the integration of a new protocol, some new authentication scheme. Maybe you came up with something to, instead of traditional JSON web token authentication, you have something based on like Ethereum private keys, or pretty much anything you can think of. Any kind of like account abstraction based like authentication model can be supported by a new plugin in this DIN router. So we are trying to design this as an open framework. Back in 2019, when we had first announced this, we had said that this was going to be an open framework that people could extend. Ooh, running out of time, I'm going to have to speed up. The federated architecture looks like this right now, which is Infura, as I said, acting as the initial gateway to the network, passing traffic to the DIN router, which is where we're tweaking the parameters of how traffic gets routed, how much goes to this provider versus another provider, and then we can also play around with different methods of accepting payment for services. I'm going to skip this little bit right here, but in this federated phase, not everybody is running the same infrastructure. Someone might be running a highly indexed stack. Somebody might be running something with more persistent sessions going directly to nodes. We're not trying to say what people run. We're just saying that you need to pass certain validation and performance criteria to be accepted into this network and capable of serving traffic. The bounty program, as I said, is live right now. If there's people in here launching new protocols, layer 1s, layer 2s, app chains, this is something that we're able to help get people RPC access or API access to your new network. And you can reach out to us if you have any questions. Gonna have to speed up challenges. Iris, do you want to take it?
Yeah, sure. So I've got my slides here, so excuse me if I'm looking down. So in terms of challenges, we've got, obviously there's a bunch of challenges that we need to solve on the DIN level, but the ones that we're focusing on right now are moving beyond the federated states. So, the potential for a DIN foundation. We've got the quality of service, which, we're always trying to figure out ways in which we're testing new partners and we're trying to be fair when we're doing that. And also in building the watcher specification, and in terms of the economics is building the on-chain registry.
Yep. Really quick on the R&D next steps, that node kit is under active development. We're adding support for more like high storage, high throughput networks, new protocols like WebSockets and gRPC. And then lastly, working on the first version of on-chain settlement, which is how you move from traditional fiat payments going out to these providers to something that's on-chain and tokenized.
All right, and just to close out the presentation, if we could go to the next slide, we want to leave you with one thought, and that's not that we don't know how to make slides, but rather that there's a lot of challenges that we need to solve on DIN, and these are just some of we're just scratching the surface with this presentation, basically. And last but not least, I just want to save you a few headaches, but what I initially tried to do with this presentation is add a sprinkle of ETHDenver. So I asked ChatGPT, how would you say thank you in Spork Whale? And this is what it came up with. So thank you for all your time and attention, and trill ondulation.
All right, thank you.